Dear children, how are you all? Hope all are fine and doing well. Welcome to the third module of our chapter Force and Laws of Motion. In this module, we are going to discuss about momentum and Newton's second law of motion. Children, we have seen in the last module that an object continues to be in its state of rest or of uniform motion until an external force acts on it, and this is known as Newton's first law of motion. So, an external unbalanced force should be exerted on an object to change its velocity, that is, to accelerate it. Now, we are going to study how the acceleration of an object depends on the force and how do we measure this force. You all know that the acceleration of an object which is falling downwards under the force of gravity is the same. A coconut falling on someone's head from the coconut tree may cause an injury, but a plastic ball will not be causing it. Similarly, when a cycle moving with a speed of 10 meters per second hitting a person may cause an injury, but a truck with the same speed may lead to the death of that person. Even though these vehicles are moving with the same speed, the impact they produce are different. This impact of force we call as momentum. It depends on their mass and velocity. Also, for a greater velocity, greater force to be exerted on the object. An external force will change the velocity of an object or it produces a change in momentum of the object. This change in momentum is not only determined by the magnitude of force exerted but also by the time duration of force exerted on it. Please watch the next video to make this concept more clear.
What is momentum? Let's consider that two objects are falling down from a height of 200 meters. Let the mass of this object is 5 kg and the mass of this object is 50 kg. These both bodies accelerate with the same speed towards Earth. If I ask you to catch one object out of these two objects, which object would you choose to catch? I am sure you will choose the object of mass 5 kg. Is it because the mass of 5 kg is less than 50 kg? The answer in physics is no. It is because the momentum of 5 kg body is less than the momentum of 50 kg object. In physics, we define momentum as the cross product of mass and velocity. We denote momentum by P. Hence, P is equal to mass and to velocity. We know that velocity is a vector quantity. Hence, momentum is also a vector quantity. The direction of momentum is same as the direction of the velocity. Now, how can we calculate the SI unit of momentum? As we know that momentum is equal to mass into velocity. Our momentum is equal to m and to v. The SI unit of mass is kg and the SI unit of velocity is meter per second. Hence, the SI unit of momentum is kg meter per second. This unit of momentum tells us just the quantity of a motion present in a body or in a mass. Now, how can we calculate the momentum of an object? Let me give you two cases. In case 1, if a person is standing on a road, suddenly a bicycle of mass 50 kg moving with a velocity of 60 meters per second hits the person. As a common observation, the person would only be injured. Now consider the same person in case 2. If this person is standing on a road, now suddenly a truck of 2500 kg moving with the same velocity of 60 meters per second hits the person. As a common observation, the person may die. Can you guess that a person in case 1 is only or merely injured, while the person in case 2 is either died or in serious condition? Although both the bicycle and truck were moving with the same velocity of 60 meters per second. I hope that your answer would be the difference in masses. If it is so, then you are 100% right. Let me explain these two cases in physics. In case 1, the mass of bicycle is 50 kg. It means mass is equal to 50 kg and its velocity v is equal to 60 meters per second. Hence the momentum p of the bicycle is equal to mass of the bicycle and the velocity of the bicycle. Now putting values in the formula. P is equal to 50 kg and to 60 meters per second. We get 3000 kg meter per second. Hence the momentum of bicycle is 3000 kg meter per second. In case 2, the mass of truck m is equal to 2500 kg, while the velocity of the truck is 60 meter per second. Hence the momentum of truck p is equal to mass of the truck and to velocity of the truck. Thus p is equal to 2500 kg and to 60 meter per second. We get p is equal to 150,000 kg meter per second. So the momentum of truck is 150,000 kg meter per second. This shows that the momentum of a bicycle is smaller than that of the momentum of a truck. Therefore, a person is merely injured in case 1, when it was hit by the bicycle, while in case 2, the person got serious injuries or death when it was hit by the truck. At last, let me teach you, does a stationary body possesses momentum? To answer this question, let me give you another example. If a car of mass m is stationary or at rest, its velocity v is equal to 0 meter per second. Hence, its momentum is equal to p is equal to m into v. Thus, p is equal to m into 0 or p is equal to 0 kg meter per second. It shows that if an object is at rest, its momentum p would be 0, or we can say that the momentum p of an object would be 0 if the body is at rest. I hope you have learned the fundamental concept of momentum. Thank you very much for watching this video.
Momentum is defined as the product of mass and velocity of an object. Its SI unit is kilogram meter per second. Momentum is directly proportional to mass and velocity. Momentum has both direction and magnitude. It's a vector quantity. Its direction is same as that of velocity. Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum of an object is directly proportional to the applied unbalanced force, and it takes place along the direction of force. Mathematical formulation of second law of motion gives the equation for force F is equal to ma. For this derivation, Consider an object of mass m moving with an initial velocity u. We change its velocity to v by applying a force F in a time t. The initial momentum of this object is given by mass into its initial velocity, that is equal to mu. The final momentum is given by mass into its final velocity, that is equal to mv. The change in momentum is given by final momentum minus initial momentum, that is equal to m into v minus u. The rate of change of momentum is given by m into v minus u by t. By Newton's second law, force is directly proportional to rate of change of momentum. Therefore, we can write F is proportional to m into v minus u the whole divided by t. When we change the proportionality sign, we will insert a constant k and the value of k is equal to 1. Therefore, F equals k into m into v minus u divided by t. When we substitute the value of k equal to 1, F is equal to m into v minus u by t. But we know that v minus u by t is the change in velocity by time, and that is the acceleration. Therefore, we will get the equation as F is equal to ma. This is the equation for force. The SI unit of force is Newton. The force becomes 1 Newton when the mass equal to 1 kilogram and the acceleration is equal to 1 meter per second square. So the force is said to be 1 Newton if it can produce an acceleration of 1 meter per second square on a body of mass 1 kilogram.
Do you remember the Newton's first law of motion? It says that an object will continue to do what it's doing unless acted upon by an unbalanced force or some net force. Now the important question is, what happens when there is net force acting on an object? That's precisely what the second law of motion will discuss. Do you remember understanding the first law of motion with a simple diagram? If the forces are balanced, the acceleration will be zero. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction. Don't forget, these two cases will remain true only if the forces are balanced. Only if the net force is zero. Now let's try to create a similar diagram for the second case. If the forces are unbalanced, then there will be acceleration. We saw that in the previous video. And now we come to the interesting part. Let me ask you a question and I'm sure you can answer it. On which two factors do you think the acceleration will depend on? I want you to tax your brain a bit. Let me repeat my question. On which two factors do you think will the acceleration depend on? Okay, let's say there's an object on a table. You apply a net force of 10 units on it. And then you apply a net force of 20 units on it. In which case do you think the acceleration will be more? Of course, the one in which the force was more. So we can say that one of the things the acceleration depends on is net force. If it's more, then more will be the acceleration. If it's less, then lesser will be the acceleration. Acceleration depends directly on the net force. Come on, now I want you to think about the second quantity the acceleration will depend on. Let's say there are two objects on the table. One has a mass of 3 kilograms and the other has a mass of 5 kilograms. Now, if you apply net force of 10 units to each of them, which one do you think will accelerate more? Surely it's the 3 kg one because it has lesser mass. Lesser the mass, more the acceleration. And more the mass, lesser the acceleration. Hence we can say that acceleration depends inversely on the object's mass. If you understand this concept well, then understanding the second law of motion will be very easy. Mathematically, it can be written like this. In simple terms, the acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. That's the second law. Or as more people understand it, like this. The net force is the product of mass and acceleration. With this, can you tell me the units of force? That should be easy. The standard unit of mass is kilograms, and that of acceleration is meters per second squared. So the unit of force is kilograms times meters per second squared. And this is what we call as Newton. 1 Newton is 1 kilogram times meters per second squared. So if the mass of the object is 10 kilograms and the acceleration is 10 meters per second squared, then the force will equal 100 newtons. We can say that 1 Newton is defined as the amount of force required to give a 1 kilogram mass and acceleration of 1 meter per second squared.